All right, so last time what we started doing is we started writing a miniature version of Quill. And so what we saw was to do something like this. What we need is we need a couple of components. We need something to recognize this as a syntax tree element, or we need something to recognize this as part of like a function that's part of some object, right? Like something like dsl.query, right? It's a function on something, some object. Right? We needed something to recognize that and then parse it into an abstract syntax tree. By the way, the object that carries this function is called DSL because this is like the domain-specific language of Quill. So once we had that, we needed to basically, first, in order to provide the infrastructure for that, we needed to write the macro of quote, like what quote actually is. So we wrote it. And then inside, it needs to do a couple of things. It needs to start by parsing, right? So there we parsed dsl.query. We then returned entity. And what we realized we needed to do to actually return this thing, because this is a runtime value, and you can't return a runtime value from a macro because macros don't run at runtime, they run at compile time. So you need to return an actual compile time piece of code, right? Macros do not return values, they return code. Anything you return from a macro has to be code, right? This here is not code. This is a value that's computed. How do you turn a computed value into code? Well, you write something called a lifter. And that lifter basically is going to walk through your possible values that you can have, which you kind of need to know in advance. And then what you do is you take that and you emit the code that represents those values. You push out the code, and that's where we got. Now, eventually, a lot of things happen after this. Like, there are a lot of transformations and tokenization that ultimately results in an SQL query. We don't need to know that right now. We don't need to go through that, because all of that has already been written. It's done. Our job here is to just return a syntax tree that Quill in the downstream stages can handle. So we started by writing a toy syntax tree here, right? And we continued to write a toy DSL. And we'll stay with that for now. Eventually we'll plug in the real Quill DSL. But I want to go a little further with this and actually show you how this thing develops. Because the one thing that we haven't yet covered is we haven't covered the unlifting part. We haven't quite gotten through that yet. So let's figure that out. Or let's implement a little bit more, right? So last time we implemented this quote thing, right? So let's run it again. Right, let's print this thing. Let's launch SBT. Let's compile everything. Run main, and then use simple Quill 2. There it is. So we've parsed it, and we've actually returned this. But again, this is already what's been computed during runtime, right? This is an inline thing that's code that has been returned already during compile time. So how do we see what this was during compile time? How do we know the value of this inline variable during compile time? And how do we know what code this macro actually shoved into this variable that this inline thing is holding on to? Right? So that's where we had this printing macro thing, where we defined this thing called print mac. Print mac apply. But again, we don't need to do apply because you can skip that part. Print mac of q. Now here's the interesting part again. Print mac is a simple macro that just takes whatever came in and it just prints it. Now, we use this thing to print what this was, but again, we print what it was not during runtime, but during compile time. Right? So you don't actually run it, you compile it. And during the compilation, voila, it prints it. This is the code that our abstract syntax tree thingy has emitted when we went over here and we said, okay, do this. Right? This entire code over here is what came out. Now, this is a little obtuse, right? There's sort of a lot here. And we worked through this last time. Like, we worked through what all of this means. So we can actually go through it one more time. See. Right, this is a big abstract syntax tree, and the thing that you have to realize that most of this you actually don't care about. So, select of ident of quoted.apply. So this is quoted.apply. Okay. So this is basically create the quoted object. Fine. What do we put inside the quoted object? These are the arguments that go to quoted.apply. What are the arguments? And now there's a bunch of irrelevant stuff. This is an applied type of a type reference, blah, 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 blah. It's org dot. Org is a module, right? It's a package. Org stuff is a package. It's another module. Org.stuff.query. Oh, we know what that is, right? We implemented that, right? No, not there. Yeah, this, right? This is org.stuff.query, right? So we know what that is. Okay, great. Blah, 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 blah. Blah, 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 blah. Okay. Oh, yes, and there's some more details here. Because it's in this module over here. Because it's called simple Quill 2. Again, more irrelevant stuff. Here's what actually is important. It is a query of person. Okay. What is this? This is quoted apply. Type apply. What is a type apply? Right? Well, an argument apply. If this was an argument apply, if this was a regular apply, and this would be ident foo, right? Then this would be apply a foo. But it's not an argument apply. It is a type apply. What's a type apply? A type apply is this. Oh, and what goes inside here? Well, it's just that, right? Because this quote-unquote type tree, this type tree thingy here means that. Okay, so there's our quoted dot apply. Okay, actually, this whole thing is, so this is in here, right? This is just, excuse me, this just means that, right? That just means that. And so this means that. Okay, right? That's the type apply. Oh, and now inside, right, like outside of here, there's a real apply. Right now we're applying actual things. Oh, again, blah, 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 blah. List of, what are the arguments? Oh, entity. Right. What is this? What is select entity.apply? Entity.apply. Okay, that's that. What's inside this entity.apply? Well, that's this list here. That's the string person, right? That's the list of arguments. This is the list of arguments that go inside of this apply over here. So this whole thing here is this thing applied to the arguments, right? So that's what this whole block means. Oops. That's what this whole block means. Okay. So now we have all of this, which is then applied to all of this, right? Because this apply is what these list of arguments are going to. So then you're going to have out here, which is just all of this, which is applied to all of this here, right? Which is just this one argument over here. Okay, which is just going to be that. This is apply, excuse me, like that. Okay. This is actually, this is a list of, this is that, apply, that. Not sure why there's an apply here. Anyway. And then finally, all of this stuff out here, again, org dot stuff dot query, and all of this stuff here, this irrelevant stuff on that end of person, blah, 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 blah. Woo, look at that. What is this? Typed is just a type description. What this means is this, ascribed, quote unquote, to this type. Right? So that's what all of this stuff means. Or more simply, quoted of query of person, person ascribed as query of person, which is really, this is not even necessary. So this is just that. That's basically all that this stuff is. Oh, and by the way, if you what was I going to say? Oh, yes. Oh, and by the way, if you just want to see the code and you don't want to see that giant tree, you just want to see the Scala code that this thing represents, let's change our printing macro, or in fact, let's do print the long version. The short version, print line, expr.show. I believe. Let's recompile. Voila. The short version. Oh, look at that. This is basically what we had before. Quoted dot apply org dot stuff dot query. Oh, that's right. It's actually person is part of this package. Okay. Whatever. Entity. Oh, and by the way, there was quoted dot apply. There, I think there was another apply in between here, but maybe not. Entity of person and all of this stuff, quoted of query of, again, person. Okay, so we are sane, right? We're not crazy. Like this is what this actually means, right? And we can actually look at that right here by doing expr.show. So it'd be really nice if this could be like shown as, you know, formatted with all of the indentation, but they unfortunately don't have that. But anyway, so there's the code that gets returned and shoved into this variable during compile time. Okay, so let's, right, that's what we did, right? That this really is the same as that, or it's what gets returned from that once this thing is parsed, right? Because this thing gets parsed into entity of person, right? Which is entity.apply, but we can apply can be sugared out, right? And really it's quoted entity of person. But it's also typed. It's typed as a query of person, right? And query was our DSL.query. Okay. Does all of this make sense?
Yeah.
Okay. Okay. So let's go a little further and let's implement a few other things. Like presumably what we want to do is we want to be able to do .map at some point, right? Or .filter, right? Let's look at how those things work a little bit. So let's try and write. First thing that we need is we need a DSL for them. So let's look at what they look like. Okay, so there's map. There's map. There's flat map, which we can do later. There's filter. Okay, how do they work? Okay, well, let's look at filter first, right? Filter has a couple of components. Filter has, when you do something like q, which is your pre-existing query.filter, right? So let's say val p equals to quote query person, right? And then you do .filter, okay? And then you do something like p to p dot name equal to Joe. Okay, so there are a bunch of components in here. Now, let's just say that this is some expression. We're not exactly sure what it is yet. We'll deal with it later. But this is roughly what it looks like. So filter really has three components. It has the thing that filter was called on. It has this identifier, which is the argument that gets passed to filter. And we have the expression, which is the body of the filter clause. So, case class filter, okay. Then we have the query, Q, let's just call it. Or, yeah, let's do query. Right, query is the thing that we're filtering on, okay. Which is going to be another AST element. There's the P, or we typically call it the alias, right? There's this thing, which is going to be an identifier. Okay, so now the plot thickens. We actually need an identifier. Say it has a name, which is a string. Oh, and by the way, extends AST, extends AST, extends AST. And finally, there's the body of the filter, which is this expression, which is another AST. So that's the filter. Okay. Now let's look at what the body might be. The body might be a p dot, let's say, name equal to Joe. Well, that's a bit to unpack. First, you need a notion of what p dot name is, right? Normally in Scala AST land, it's ident p select name, apply, and there are no args, so empty list. Sometimes you don't need an apply, depending on the situation. Okay, right, but what is this going to be in Quill land? Well, in Quill land, we make this simpler. Now, by the way, this can also be p.name. Because maybe p is an embedded entity. So maybe you want to do something like case class person name name. And you want to do something like case class name first string last. See, you might want to do something like p.name.first, which means that you're doing something like select and then select of that, right? But for the Quill AST, oh, by the way, this is going to be list, right? Because you don't know. There could be multiple arguments. This could be name of, oh wait, no, sorry. No, sorry, I'm wrong. I'm being incorrect. Sorry. No, it can't be like that. It can be multiple arguments, but if there were multiple arguments, it would be an apply. Right? If it was AB, it would be apply on list AB, but it's not, so, or it's not that, it's this, so there's no apply. I don't think there's apply, at least, right? It's that, so, sorry, no apply. So yeah, but we kind of want to implement a simpler DSL for this, maybe, because, well, in Scala land, this is typically going to be something like identifier of that. It's a little more complicated, right? And if we want to see what this kind of thing actually looks like and not just guess, it's pretty darn easy, right? It's super important to, like explore what these things actually look like. So let's comment this out for a second, right? And then let's do something like print mac of, let's say val p equals to person Joe. Print mac of p dot name. Let's compile that. Okay, the short version is that. The long, oh no, something failed. Ah, ha ha ha. Well, we just introduced a whole bunch of other stuff that AST could be. And Scala knows that if you have a sealed trait on AST, AST can be this, or this, or this. Ah, but then when we do something like, say, case match entity, where AST is of type AST, come on, give me the type. Loading. Sometimes when it doesn't compile, it has trouble. But AST is of type AST, and it's not, wait a minute, there should be some other cases in here. There should be this possibility and this possibility, so it gives me a warning. Okay, let's just comment these out so that we can get past that. We'll re-enable them in a minute. Let's recompile. Okay, the short version, the long version. Okay, this makes sense. I actually expected this to be ident also. I'm not sure why that's the case. So we can play around with it, and we could do something like case class name, first string, last string, and we could do name is going to be name, age is going to be int. So then we could do p.name.first, and let's see what it prints for that. Oh, wait. P.name. What did I do wrong here? Oh, right. You can't do person of Joe anymore. This has to be person of name. And then Joe blogs. And let's say 2.3. Right? And again, this is going to be person.apply. This is going to be name.apply. Alternatively, right, because again, they're case classes, so all of these things come with an automatic object person, right? And then that has an apply that takes a name and an age. Right? All those things come built in, but you don't need them. If you want to use the constructor directly, use new. Right? So, okay, just as a big FYI. Okay, so then we can construct one of these properly, and voila! There's the long version. There's the short version. So, right? Because that's what we passed into printmac. So anyhow, to make a long story short, super, super useful to print out the actual AST. Oh, and by the way, this is not exactly the truth. If you want to know what exactly the truth is, you have to do something like, why is this loading constantly? You have to do something like, This is weird. I actually don't remember what this is. There was a function here, but I don't remember off the top of my head what it is. Show extractors? I believe that's what that is. There we go. Oh, and you just want to do line. You're going in that direction. Oh, right. Excuse me. Because this thing compiled successfully, I have to modify it to actually recompile it. Okay. Oh, wait. What did I just do wrong? Oh, sorry. pprint.apply. I'm still pretty printing it. I don't want to pretty print it in this case. And again, I have to modify this file. Because the compilation is successful, it will not recompile. There we go. Okay, so this is how I can actually match it, right? If in print Mac, I wanted to match the AST, I would do something like expr.unseal.match, and then this expression here. Or if I wanted to actually get the strings, right, I could just make them into variables, right? Because what show extractors does, which is this nice little thing here, which is it shows you exactly what you need to print in order to get whatever the thing that's shoved into here is. Fine, whatever. Does all that make sense so far?
Yeah, I don't have any.
Yeah.
Okay. All right. So now let's go back to where we were before. It's so annoying that in all Microsoft products, redo is Control Y, and in every other product in the world, redo is Control Alt Z. Or sorry, Control Shift Z.
Yeah.
So freaking annoying. Anyway, it's like, oh, Visual Studio Code is a Microsoft product.
I mean, you can change that, right?
Yeah, I know. You can change that. Yeah, that's in File Preferences. Keyboard Shortcuts.
We won't follow your religion.
Yes, this is my religion. This is definitely my religion. Oh wait, there is Control Shift Z. There's also Control Y. Interesting. Anyway, let's see. Control Z, Control Shift Z. Oh, because I think Control Alt Z, because Alt is Command on OS X. Okay, my muscle memory is really wonky. Anyway, so now let's try to implement a little bit more. Let's try to implement this dot map. Okay, so we started doing this. I want to kill this thing and relaunch it because this is just wonky.
Wait, Alex. So, is there any talks about IntelliJ supporting, Scarlet 3?
It
because
sort of does already.
Okay.
I have not tried it out. I think you can use it if you have the latest nightly beta versions coming out of IntelliJ or whatever that is. Like you can set IntelliJ to use the latest beta version, and that will let you compile.
Oh, that's cool. But yeah, so yeah, that's another thing. I think all of us, we're going to have the JetBrains IntelliJ Ultimate.
Yeah, there's one issue with that though, which is that IntelliJ has always had trouble with Scala macros. Right? Remember how in parsing.scala there are all of these squiggly underlines, and it says that things are wrong that aren't actually.
Oh, yep. Yep.
So
I mean, not just that. Even in cats, I remember seeing so much red
yeah,
everywhere.
well,
Cool.
that's just IntelliJ like not being able to figure everything out in time, and as it tries to figure out some things, it tries to figure out other things before it tries to figure out the first things, and so it just gets confused. The last time I tried IntelliJ for Scala 3 was like 6 months ago, and when you tried to write anything with macros, it would just give up. And it gave you, any file that used macros gave you no type inferencing, like very little in the way of helpful stuff. So I sort of gave up on it, but I'm sure that if you have the latest nightly build, they've probably improved on that. So we could try it at some point. It's definitely worth a try. And I'm pretty sure that as Scala 3 comes out, which it will in like 3 to 4 months, they'll add better support for it. And definitely because I'm really hoping that, unlike in Scala 2, where macros are kind of not really well supported by IntelliJ at all, in Scala 3, I'm hoping they'll be better supported because they actually are built right into the language. So, for Scala 2, they're sort of built into the language, but not really. But I'm really hoping that with Scala 3, they'll get the story with macros right. So, we'll see. But anyway, let's see. Does this give... Okay, yeah, now this is giving the correct thing. Right? There's the type. Quotative query. So, okay. Now, let's take a look at our miniature implementation of Quill again. So we realized that if we wanted to implement filter, we needed to implement identifiers, because this thing here is an identifier, and we actually need to have a way to implement the body, which is usually going to be some comparison statement. But first, we need to have a way of pulling out a property from this guy, which is also an identifier, right? So this is what something like, let's take out the stuff here and let's just do that. Something like this is typically going to be constructed like that. Quill doesn't use, or no, it's not that, it's that. Quill doesn't really use select, it says property. And it's going to be ident_p, and name is going to be a string. So let's implement property. It has another AST inside, right? Because you could have a property within a property, right? Because it could be name.first and name.last. And name, right? That's actually, or let's say value, right? That's this thing here. That's not really a value, it's the name of the property, so we'll go with name. Okay. What else do we need? Well, we need some way to represent this. We need some way to represent this. Okay. Well, how do you represent this? Well, again, in Scala, it would be something like select from this, and again, because everything is a function in Scala, this is really that. And so, in fact, this would be that. And then it would be apply on a list of arguments, which would be constant Joe. But again, for Quill, we kind of want something simpler. So in Quill, we have this, and in fact, in SQL, we want something to represent, like, what this thing actually is in SQL. So in Quill, it's binary operation, which is a little bit more natural in some ways, right? It's a binary operation. On one side is this, right? On the other side is constant, which is Joe. Oh, so we need to implement constant. Let's say value, which is a string so far. Okay. What else? And then, of course, we need the operator. Okay. Well, let's make some kind of enum for that. Let's say operator. Let's say case class, or let's say object equal equal. Okay, so then equal equal, or in fact it's a case object in this case. So this is going to be equal equal. Oh, but wait a minute, in Quill you can do symbolic names of things so long as you put those squigglies around them. Neat. So operator dot that. Oh, and maybe it'll be easier to put our operator in the middle. So then we have an implementation of binary operation, which has the left, which is an AST, operator. Oh, yes, we need to make a class for operators. We can make it into an AST, but that doesn't really make sense. That's an operator. So there's an operator, and there's a write. Right, because, right, you could just flip them like that. Right, so you can flip the left and the right, obviously. So, okay. Right, so now this whole thing, t.name equal to Joe, this would be roughly what it would be in Scala, but this is the Quill sort of AST. So it's a little bit, it's actually less generic. Like, this is super generic. Remember, that's not even property, it's select in Scala AST land, right? This is super generic. This is way more specific, right? We have specific things here. We have a specific list of operators that can be contained within a binary operation. Okay, so let's see what extends AST. This has to extend AST, this has to extend AST, this has to extend AST. So now we have to be able to parse all of these different things. Right? We have to be able to parse ident and filter and property and constant and all of this other stuff. So this is how Quill gets complex, because you need to support many kinds of operations. So let's start. let's have filter. So let's do oops. Let's do case DSL.filter. All right, what do we do then? Well, we need filter that takes some kind of lambda expression, which is P2. Okay, filter's not. Oh, sorry, it's. This is not going to be DSL.filter. This is going to be some query.filter, right? But when we're doing something like query of person.filter, or in fact we could do val q equals to quote of query of person, and this is going to be not a val in Scala 3 but an inline def, and then this is going to be quote of q.filter. Well, this could be q, which is a variable. So let's ignore what's inside of this for a second. Let's just call it body. Okay. What's this? What's this guy? Well, that's tough, because this could be any variable. Oh, right. Scala 3 doesn't like something that can be anything, because it wants these matching blocks to be typed. Okay, so how do we do that? Well, the way that we do that is by doing a type description, like that. And now, but wait a minute, query can also take a type parameter, but it can take any type parameter, so it's any type parameter possible. Okay. Well, this is getting interesting. So this is query.filter and the body. Well, let's try and return our filter element, right? That's the AST that we need to return, right? Because this p2 p.name, right, as we saw before, this is going to be filter of ident of q, and then this is going to be ident of p, and this is going to be property ident p name. So we need to take this and generate this out of here. Okay. Well, we have this. Oh, do we? Well, we need to parse this. How do we get ident this? Right, this query is of type ident, actually. Right, like this query here, its tree element in Scala land is actually going to be an ident. Right? Here's what I mean. Let's just add case. I have no idea. Actually, you're not supposed to do it like that. What you're supposed to do is let me quickly check. Yes. You're supposed to use the quoted context, which we have here. Again, it's kind of dangerous to just randomly throw errors inside of macro functions, because those macro functions run during compile time. So there's a special construct for actually throwing errors when you need to and failing the whole macro. So that's qctx.throw_error. Cannot parse the tree. And then let's just put the name of the, let's just put the code inside. And this is going to be expr.show. Don't need those in Scala. So let's just quickly, right, this query, the tree element is actually going to be an ident. And let me show you what that means, right? So when you have something like, val q equals to, let's say person. It's actually going to be query of person. Let's just say person. And let's remove all this unnecessary stuff. Joe. And then let's say that person has a function called filter, or let's say case class query, and that has a body, which let's say for the time being can just be a person. Or let's say query of t. And then let's say it has a body, which is of type t. Let's say def filter t2r. T is of type t. We need to define an r type. Oh no, sorry. Excuse me. T to Boolean. And then we return a query of t. And then let's say that yeah, let's just keep it that way. Now, or let's say this is just going to be a query of t. We don't really care about it here. What is this? Oh, let's say this is a function, right? We're just playing around here. This is body. So there's q, and then let's do print mac of q.filter p2p.name. Okay. Sorry, this is going to be query of person. And let's say, actually it doesn't even matter what we put here in the body. We could put null, but whatever. And let's just put an object here and not found q. Why does it say q is not found? Oh, whoops. There we go. P2, T2 Boolean. Oh, right. P2p.name equal to show. So let's compile. So Q is an ident. Yeah, let's just see that. Let's do file. And there we go. So this whole thingy here is this thingy here. Sorry. This whole thingy here is this thingy here, right? That's what goes inside a print map. And you can look. Oh, yeah, that's right. Q is an identifier. Unless, of course, it's an inline def, at which point, right, everything that was here gets substituted into there. Right, so now we have this whole enchilada that like got substituted, which is all of this stuff here, right? And then eventually we call the filter function, right? This stuff here is coming from this variable that got substituted into this expression, again, because we made it an inline. Okay, so Q can be a couple of different things when it gets inside of this expression over here that we're trying to parse, right? It can be an identifier, it could be a full query expression. There's a bunch of stuff that it can be, right? So we need to continue to parse this thing. Right? This could be an entity. This could be a bunch of stuff. So what we need to do is we need to run our parser recursively. Right? So what we do is we need to do parser.apply, right? Run our parser recursively like that and actually parse query. Right? So we want to continue to parse it. Let's actually val query ast equals to parser.parse, or apply, right? In regular Quill, this is ast parse. I should probably rename it too, come to think of it. Let's see, let's call it ast parse. Let's call it ast parse. Let's call it ast parse. Right, just for the sake of consistency. Okay, so right there's our query, and this is gonna, and now we can just do that. Okay, then we need to parse. Then we need to parse the body. Well, we need two other pieces of information to construct a filter. What do we need? We need the identifier that was used in the body. And here's where it gets tricky. You cannot do B2, or this is like the alias to the expr. That does not work, unfortunately. There's in Dotty there is not such a construct. Did I mess up here? Oh, yes. Aha. Query of question?
Alex, I'll have to leave. I have a meeting with Rajiv.
All right, I mean, go do what you need to do.
Okay.
This, this will be on video, hopefully.
Yeah. Okay.
Yeah, of course.
Yeah.
Yeah, thanks for telling us. So this is gonna be what? This is gonna be query of T. We're trying to recursively parse it. I'm not sure why that issue is there, but let's leave that alone for now. The bigger problem is we cannot do this. Not a legal formal parameter. All right, so let's try to compile it. Okay. So yeah, okay, 1 second. What is this? Found unit. Oh, right. Because this whole expression here has to return an AST, right? But if we haven't actually returned an AST from this expression, right, what's the output type of this whole thing? Right? Every single case needs to return a type which is AST, right? Because this is the same as assigning, let's say, val parsed tree equals to that, right? Parsed tree is an AST because this whole thing returns an AST, which means that every individual clause of this has to return an AST. Does that make sense?
Yeah, it makes sense.
Wait, hang on a second. Can you repeat that one more time? I think it's just one more time.
No problem.
Yeah.
I can demonstrate.
Oh no, it's okay. Like you just repeat that thing. I think I might have missed it. I can watch it again.
Let's say val v int equals 2. Let's say 34 match. Let's say, I don't know, 34 dot to int. This being complicated for the sake of being complicated, right? Case 1, then return 1. Case 2, then return 2. Case 34, then return, yay, problem. Problem, what's the output type going to be of this case match expression? What's the output?
Any? Oh, yeah.
This is int. Ooh, problem. Right, 34. We have to have some other integer.
Oh, this will actually return... I mean, this will actually give a compilation error then?
Boom.
Yep.
What happens if the last thing you do inside of an expression like this is val blah equals to something? Any kind of assignment.
That's still nothing. Like, that's none, isn't it?
Close. This doesn't return none. This returns unit.
Oh, unit. Yeah.
Remember in Scala that a function that doesn't actually do anything is of type unit.
Yep.
Okay.
Mm-hmm.
This statement is of type unit. So if you do something like do an assignment as the last thing inside of a particular clause, and the thing that comes out, which is AST, or the whole thing that comes out of the function is AST, and the last thing we do here is a unit, we're in trouble. Right? Because the last thing you return from this clause cannot be a unit.
I see.
Well, we don't really care about this right now, so we have this wonderful, horrible thing called null that we could just use in here, because we plan to fix that anyway. But anyway, or we could just, again, do...
Wait, so null is also the type unit? Is that it? No. Or null is of type null.
What is the type of null?
Wait, null is the base, isn't it?
Huh?
Null...
Ding, ding!
Oh, it is the base. Okay.
Null is close to the bottom type.
Okay, yeah, all right.
Right, remember the Scala type tree?
Yep.
Right, so null is at the bottom of the tree.
Cool, yeah.
So yeah, null is like a subtype of unit. Right? You're on a mountain. At the top is anything. At the bottom is nothing. You go from anything to mammal to animal to vertebrate from anything to vertebrate to animal to mammal to dog to Labrador to spotted Labrador with 3 missing teeth to all the way down to specific until nothing. Because there is literally nothing that is so specific that as the thing that you're describing, right? What happens when you have described every subatomic particle of the thing that you're describing, but there is no such entity with that subatomic particle configuration in the universe? What is the type that represents that? Nothing. Okay, so, or we could just return an error, which is the same as returning nothing. Okay. But the point is that we don't know what this and what this are. We don't know what this is, and we don't know what this is. We can't parse an expression like that in Dotty macros. Sadly, you cannot parse expressions that represent lambdas. So, and I mean, you can try and type them. Let's see. Yeah, there we go. Perfect. Let's see. So the type of this thing has to be the same as the type of this thing. Right? You could do some kind of T here. That could be it, right? Because the T inside of here, right? If this is person, then if the type of this is query of person, the type of this is person. So if the type of this is query of T, the type of this is T. So let's see. We've typed it to T. It still doesn't like what we're doing. Well, this expression we know. This is a better deal. We know that this is a Boolean, so we can do that. Still doesn't like it. Hold on, that's type description. What did we do here? Oh, no, blah, 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 sorry. My bad. No, again, that's not the right syntax. The right syntax is that. So we can do that. The only trouble is this. Right, again, that's the wrong syntax. The right syntax is this syntax. We can do that.
Can you hover over it?
Huh?
What's it saying? Can you hover over it? What's it saying?
Huh?
Can you hover over it?
Well, it's saying the same thing as it complains when you try to compile it, which is that you're declaring a new thing, a new variable called T, but T was already declared here. So then it's like, guys, we have T and we have T2. That doesn't work, right? Because basically, effectively, I'm saying this and this are two different things. So let's declare another type here. And then it has another issue, which is, oh no, gosh darn it. This here has to be the same as this here. We found T, but we're required to do T. So we can't do either one. So they gave me a trick to try and get around this problem. The trick is the following. Let me find it in here. There we go. They told me to do that. So basically define some type externally and then use that type in here, but in this case we use these nice funny little quotes, and then we use these funny little quotes here, and that's supposed to tell the compiler that this type that we declare here is used here and there. And this supposedly is the right way to do it. I don't think this will work. Oh! It does. Despite the fact that it puts ugly red squigglies under, it does work. Okay. So let's see what will actually happen. Let's see. Let's try to actually print line pprint apply, and let's do alias dot show. Let's do alias dot unseal dot show. No, there I just print alias dot unseal. That could work, and then let's do, again, because we can't actually instrument a breakpoint debugger on this yet, we have to use these printouts, which are annoying. Okay, so we can print that out, and then let's print expr. Unseal is, did we forget to import something? No, unseal is not a member of scala.quoted.matching.symbol. Okay, just print out that. So, right, we need to actually match these things to print them out. So let's do query of person dot filter p2 p dot name, and then we need to do other things in here, but let's just make name. We can cheat. I don't care about this for now. Let's just cheat and make this a Boolean. We can at least cheat and see if this expression will work. And what just happened? What just happened? We're compiling this, and that's odd. Wait a minute, what's going on? Is it hitting this? Okay, one second. Let's see what's going on here. Got to parser. Okay. Match me. Okay. What is it complaining about? We're doing quote. And then inside of our parse. No, sorry, no, that's not what we're looking for. Don't care about that either. Quote. Parser, quote implementation. We have dsl.query, which is correct. And then we're supposed to do that. What the hell? Pattern match exhaustivity warning. Where is our pattern match exhaustivity? Oh, it's here. Again, let's throw an error if it's anything else. So I cannot lift the tree. Just ASD. What? This is confusing me. Oh, wait a minute. Okay. Oh, so this is super important to understand. Yeah. This is unfortunately where you have to know a little bit of the internals of how Java works. Let's compile again. What the heck is going on? We haven't run our macro. We haven't printed anything. We've literally done nothing. What the hell? What the hell? So, basically, what Java does is that if we never use something like Q, and it actually doesn't throw any exceptions inside or anything like that, if Java sees that we never use this variable, and this variable is a pure expression, doesn't have any side effects, if Java sees we never use it, like we never print it or anything, it just takes this whole part of the code, eliminates it. Which is why, unless we did that print line, the code was completely eliminated. This is something super important to understand about how Java works. Code that is not being used is eliminated, and if it's eliminated, the macro that gets generated there will never even be run. Will never even be compiled, because the code will just be eliminated. That's why the second that I didn't use this Q at all, it wouldn't even bother compiling it. So you have to actually do something with it. Either print the AST using this, or print it, or do something with it. Otherwise, the compiler will completely remove the code. Make sense?
Yeah.
Okay. So, all right, now we actually got to the parser, and we got to the macro, and all of our printouts are working. And where are we at? Ooh, cannot parse the tree. Yeah. This is where we start to get into a little bit of trouble. because this thing here never actually gets matched. We never actually got into here. Despite the fact that we seem to have done things right. Like here's filter, where's filter? Why, this is the way that we've defined filter. It returns query of t. Right, that's what it is, and we've parsed it, and it sort of seems right. Right? Query looks okay, and filter seems good too. So then, why does it not work? Well, the answer is, I don't know. I filed a bunch of bugs on Dotty, and certain constructs work, other constructs don't work. The trick is that now you have to play around with it. You have to play around with it until it'll work. So the way that you do that, is you simplify the expression until the match actually happens. So let's try to take this whole thing out. Let's change that to body. This doesn't exist. Just p-print body. And let's just do seal. Let's see if this works. And what happened now? Ah, yes. So look. Now we hit it. Now we actually got into this clause right here, as you can see here. So now we got a filter parser that seems to work, only we can't actually parse this expression the way that we would like to. So we have a couple of options. Sometimes it may be possible that we can do something like this. We can try matching inside of here and try redoing this process. So we could do, and again, this is not necessary because we're not using this type multiple times, we're only using it once. Hey, my name is Quill, what's up? Oh, sorry, 1 second, guys. No worries. All right, so what we could try, this type is only used once, so we don't need to do that trick. We could try matching body again. So we could try something like $T2. Again, it's going to complain, so you need a type description. Okay, what's the type? Well, we don't know. Try putting that there. Might not, probably won't work, but we could try. And then what? Some kind of body, or this is the expression. Let's call it filter body. Filter body, which is the expression, and then let's do expression of Boolean. Okay, that's what that has to be inside. Case this. Okay, so now this is problematic. All right, let's try to compile this. Oh, sorry. Filter body.unseal.
Just to let you know, I'm gonna have to go soon as well.
Okay, fine. We can 10:30 or whatnot. We can call it a night. And so now the parser is hanging because you have this kind of thing here, and then the parser is trying to search all the potential classes that could satisfy this, and we're in trouble. So you can't go about it like this either. Let's kill SVP. Let's relaunch it. So you can't do stuff like this, unfortunately. What we have to do is we have to actually climb into we're back to where we started, where we have to get gritty and climb into this tree that represents the filter body and actually pull out the identifier. Excuse me, this guy here. We have to pull this out, and we have to pull this out. So we have to get a little gritty. What's happening here? Compiling sequence sources. Okay, there we go. Okay. So we need to actually take this expression here and we need to match it. We need to match this lambda expression. Now we have to actually match this thing, block of list of def, right? This whole thing here is actually the representation of a lambda expression. And we can sort of work through that. It's a little tricky, but I guess let's work through that tonight and we can call it a day. Right? Typically, what ends up happening when you do something like p2p.name, well, when you do something like map p2p.name, this is going to be a block in here. And inside of a block, it could be a list of statements of foo bar. Okay, so let's take out this. Let's take out this. Now, what happens is when this thing is actually applied, after this thing is defined, because this is a definition and an application at the same time. So this is basically the equivalent of def, and then P, or apply on P, like that. Okay, so that's what this closure thingy here is. This whole thing here is basically a definition. Now, typically a definition foo equals to p def foo equals to p, let's say int or whatever it is, to, well, let's say person, to equals to p.name, except again this is an anonymous function, so this normally would be foo, but it has no name, so it's an anonymous function. Don't care about that. Don't care about this. Now, a list of arguments. It's actually a list of lists because a definition can have multiple argument lists in Scala. Okay? So again, we don't care about that. Don't care about that. Don't care about that. Okay. Then the value. What's the value? So this is a definition. What's this block? These are the arguments. What's the value? Ah, there's the value. Right, so this, if we're defining it, a non, what's this? This is actually a value, right? So that's this. The value has a type, which is person. That's this. Or let's say type tree of, again, stuff. The stuff dot this dot person. Okay, fine. It's a type tree of this. Let's cut all this stuff out. This, more details on that. We don't care about it now. So this is basically what a lambda looks like. This def, and of course, this over here is this inside here. So basically, that's what this giant expression over here is. Now, fortunately, there are some utilities that can help you parse big things like this. In this case, basically, the Dotty people have provided some utilities. I've provided some utilities on top. There's a parser that I've written called lambda1 that parses these things. So let's just look at that. Again, we don't need to look at the implementation of this thing in detail, but basically there's this thing that we call lambda1. And let's go here. And let's take this lambda1 and let's use it. Let's define it here, like that. So here's our lambda1 parser. So now what lambda1 is nice enough to do is it's nice to give us a string that represents the identifier and an expression that identifies the body. So in other words, all that we have to do for lambda1 is that we have to, and hold on, it takes a expression, and yeah, that should be fine. So all that we have to do for that is we have to do, instead of that, we have to do filter, and again, we're actually injecting something, so we do need a $sign, lambda1. Right, let's see how we actually used it in the parser. There we go, lambda1. This is the implementation of map, by the way. And this is going to be the identifier, or the alias. And this is going to be the body. So let's do print, pprint alias, which is, by the way, just a string. And this is the body, which is an expression. Body.show. Let's try to compile this. What did we do wrong? Oh, right. We didn't do anything wrong. We're throwing an exception because we decided to do that anytime we enter this thing in the first place. But anyway, so, okay. Body is alias. Hold on. Do we need to recompile this? 1 second. Let's try to recompile. What happened here? Oh, member not found. Quoted dot. Oh, excuse me. It's telling us the old code that we had previously compiled because it can't recompile our macro because it can't compile lambda 1. And so what needs to happen here this is incorrect. This isn't, well, there's expression, but it's not quoted.expression is just expression because we imported it. We imported it differently. So anyway, right? Quoted.expression comes from here. So we imported everything from here, not the quoted object. Okay, good. Yay! We have the p variable. And so now we not only do we have the p variable, we have the expression as well. So now the next step is to recursively parse. Well, we have query AST, we have ident AST, which is just ident of alias, right? Because alias is just a string. So we've got that. Come on, give us the type. Flaky. Anyway, then val. Finally, we need to recursively call AST parse on body. Okay. And then, once we have these things, once we've parsed all of them, we put it into our filter clause. And then we have our AST. Now, the next step is, what is the body going to be, right? When it calls AST parse on body, it's not going to be able to parse body because body needs to be property, right? We need to be able to parse p.name, right? We need to parse this. Okay, so either we can try to work on this now or should we continue next time?
Well, I definitely have to go. So, I mean, if you guys continue, I'll just watch the rest of this once you post it.
Okay. Prakar, what would you like?
I mean, it'll just be, what, the three of us. I don't know. I mean, I can keep going. I don't mind.
Okay. This is not going to take long.
I do need a moment of break.
Huh?
I need to.
All right.
I do need a moment of break.
Yeah.
Good night, guys.
Let's take a moment, and let's.
Yeah, I'll watch the rest of this.
Cool. Who's who do we have right now?
It's you, me, and Harley.
Hey, Harley.
I think he's on mute.
All right, so let's take a break and we will finish this, and basically we will have a parser for this expression. We ready to get to the next stage?
Mm-hmm. Let's do it.
All right, let's do it. Okay. So now we have this wonderful lambda 1. Now we have this wonderful lambda 1 that parses a lambda into an alias and a body. Lambda 1, because again, a lambda can have multiple arguments, so this is a lambda 1 argument. So we've parsed an alias and a body. But now we have to parse the body. Now we actually have to parse p to p.name. And this is where it gets a little tricky, because what is p.name? what is p.name? It's just ident p select name. It's just that. Well, as we've seen before, you can't do that, right? This is some people, we don't know that this is name, right? This is some ID, and this is some property, right? But you can't do that, or it hangs forever. That's a problem. So what you need to do is you cannot use expressions. You cannot use the layer of quoted matching, right? You cannot do expr, which is, right, some expr, some t. You have to use tree, the tree API or the term API. Now, right, what we actually need to do is we have to do case select ident of some ID and the property, right? And then we can actually do property of, right, ID, that's going to be a string. Actually double check that. Yeah. Prefix. Yes. Ah, right. Yes. So, by the way, we'll just assume this is an ident. Really, this doesn't necessarily have to be an ident, right? Because it could be p.name.first. But we'll just assume for now that it's an ident for the sake of simplicity. So we have ident of ID, and we're assuming this is a string and this is a string. So we can just do property of ident. Wait, this is ident and this is ident. This is io.getquill.ast.ident. This is qctx.tasty.ident, I believe. So these are two different kinds of idents. And this is going to be the ID, which is a string, I believe. And the property is also a string. Except for, one problem. Remember that you can't match this on an expression, right? What are we matching? We're matching expr, which is an expression. We can't match it on an expression, right? If we want to do something like this on expr, right? We can't do expr match case all of that.
Do we need to sort of seal or unseal it?
Yes. Right, we have to do that.
Yep.
So, but here's the thing. If we do it like that, then we can't put this here. Right, that's a problem.
Ooh, can't you apply the seal in the case on the case line? So for example, with the whole select qctx.taste yada yada yada, and then you do dot seal there, does that work? Or no?
You mean seal this?
This, yeah. Do you think that would work?
So it's case that dot
Dot
seal.
seal. Yeah. Do you think that will work?
No, but you're very close.
Oh.
You're very close. What you actually want to do is you want to take this expression and you want to unseal it before you match this on top of it. So what you want to do is you want to like have an unseal function, right? That's what you want to do. But again, we are inside of a case match. We are not inside of a function call, right? So let's imagine for a second a simpler version of this problem. Let's say that we have a string. Okay? We have some random string. Let's say that we want to match it. We want to do case, so yay, it's faux. Case, bar, yay, it's bar. Case 4. Or case I int if I greater than 10. It's a big number. Case I int. It's a little number. That isn't really gonna work.
Oh, I see.
Well, we could try to do something like def to int.
Oh, that's what unseal is. Okay. Oh, so
Not yet. Don't hold your horses.
Oh, okay, never mind then. All right.
What if we do? Well, first of all, let's try commenting them out. That's fine. Well, what happens if we do something like to int?
Would that one work? Oh wait, no, that would work.
No, it wouldn't.
It wouldn't?
We're calling to int on I. What the hell is I?
Oh, but we need to call it on str. Wait, you actually showed it to me earlier too.
We can't do that. We're
Yeah,
not
no,
inside
wait,
of function
hang on a second.
calls.
Wait, yeah, I know the answer to this. Ah, shoot, he actually showed it to me. We actually talked about a lot
Yes,
about
we
this. I
did.
was so confused. Yeah, oh, bugger.
What we need to... Okay.
Go ahead.
If
Sorry,
you are in match, you must unapply.
Yeah,
Unapply,
right.
unapply.
Yeah.
To do something inside of match, you must unapply. Unapply.
Yeah, that makes sense.
Not def to int object. And let's do capital T. Def unapply. Again, we're running to int on str.
So string, okay.
Equals 2. Now, we have a choice. We can say this does not match, or we can say this does match. Right? We can say it is an integer, it is not an integer. Okay. Try str.toInt catch case e exception. Right, that's how it works in Scala. Try that. Well, if it's an except, what is this thing going to return? Option of int. It may match, or it may not, or it may match, or it may not. It may match, it may not. It has two states. What represents two states? Option, option, option is two states because it can be some or none.
Jesus, Alex, don't sing. It's nighttime.
Sorry. If it's an exception, it is none. If it is not an exception, it is some.
Yep.
Voila. Oh, right. We need to. We are not.
Oh, I
in.
not. Yeah.
We are pulling something out. Voila.
Yep. Compiles.
Voila.
Yep.
So.
What if we comment out? I want to see the. Please comment out foo and bar. The case foo and case bar. I just want to see that. Oh, and try and yeah. Foo.
Boom. Magic.
Okay. Yeah. Yep. Just wanted to see that. Cool.
So, what do? Do we have a function? No, we have an unapply.
Unseal.
Object unseal.
Oh. Def unapply.
It takes a expr,
Take the.
some expr of something, we don't care what. It returns an option of a term or a tree. What does it do? Well, it can't not work because you can unseal any expression, so just some of expr. Unseal.
Whoa. Unseal,
Yes.
Yeah.
And what is this complaining about? Blah 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 blah. Why does this complain? Why does it complain? Okay, I don't care. Okay. Okay. Ha. So now, if we unseal, voila, this should work. And we put this at the very, very end, because this is super generic, right? Like, this is just anything applied on anything. This potentially can match other stuff in our tree. Like, if our tree consists of, oh, say, o.get or else, right? We want that to be parsed typically by a different parser, right? Because we parse optionals differently. Otherwise, it would fall inside of here.
Mm-hmm.
So this typically needs to come at the very end. And let's compile. Oh, right. Ident is ambiguous because we have imported both org.stuff. Oh, no, sorry, this is not io.getQuill. This is org.stuff. Excuse me.
Oh.
We have implemented both kinds of idents. That's a problem. So let's when we import it from qctx.tasty, let's do ident to t or tasty ident. Fine. T ident. T ident. That should do the trick. Let's see if that will solve the problem. TI does not have a member of tasty.reflection. What? Did I... One second. UCTX.tasty.tident.
With the ceremonial error, right?
Huh? Oh, right.
This is just ceremonial error, right?
Sorry?
This is just ceremonial error? Or
Yeah,
is
it's
it like-
ceremonial. But again, it's not, well, that will work, right? But I imported it as that. So it's that, which is what I imported it at, or that, which is the actual thing. But I can't do that because that doesn't exist.
It does not
Yeah,
exist.
so let's
I
just do
see.
that.
Success.
Okay. Cannot left the tree.
Wait, what?
1 second. Oh, lift. Oh, yes. Yes. So now, of course, we've gotten to the next problem. We've gotten to here. So we've managed to parse our tree. So let's remove all of this. And we don't need these variables. So, let's just substitute these. Again, this code is more concise, it's more meaningful, it is harder to debug. Annoying, so sometimes you have to change it just to be able to breakpoint debug it. Annoying, but that's life with functional programming languages like Scala. Now, so we've got some issues, like the fact that we need to be able to express, we need to be able to lift all of these new different kinds of things that we just figured out how to parse. So that shouldn't be very difficult, right? We should be able to do case... let's see, case, what do we have? Filter, right? And what do we have inside of a filter, right? We have the query, the alias, body, and again, we just do, right, lift, which is going to be that.
Body is a predicate, right?
Yes, body is predicate.
Okay, cool, yeah.
Right, and then lifter.apply, or just you could do lifter because apply is not needed. Query, lifter of alias, lifter of body, and then those, so then we need, so query, typically, right, query is going to typically be an entity, at least for now, because we haven't made things more complex. So, lifter of alias, right, that's going to come back to here. And so alias is an ident, right? Ident. So, and that's a string. And then we're going to have ident. And then the string is going to be ID, let's say val, just like we did name here. Name is a string. ID expr, which is just an expression of, right, because you can lift a constant. Or, right, and then that, which we are going to plug in inside of here. Or if we want to be concise, we actually don't need to do that. We can just take this thing and shove it right inside of there, like that. Same here, right? We don't need to declare a variable. We can take this thing and we can shove it right inside of there.
Mm-hmm.
And what else? We need a property. Now, we kind of assume that all properties are going to have an ident here. So that's fine. We could just recursively lift that. And, oh yes, of course, excuse me, right, we need to, right, because we're not actually lifting lifter into the AST. That wouldn't work. We're saying call lifter and whatever comes out of it, lift into the AST. Does that make sense?
No, I don't understand. What?
We're not, okay. Let's say we have a function call called def foo of bar, right? That we do that will like lift some additional stuff,
Okay.
right? Where, right, if we just say that, what we're saying is lift the actual function, like the code that comes out that goes back to the user is going to be filter of foo, which is wrong. Right? No, what we actually want, and let's say foo returns, foo like takes a string and returns an expression of a string. Right? We're not trying to lift foo, we're trying to lift the result of foo. So what we want is we want val result equals to foo of our query or something like that, and then we want to filter
Alex?
the result of
Hello?
that and splice it in.
Uh,
Right?
Alex?
Yeah?
Alex?
Hello? Can you hear me?
Yeah, you just cut off there entirely. Yeah, I did not see what
Okay,
you typed in.
let's
Yeah. Okay, no. So, hang on a second. So, you were not trying to put in foo there, but you're
Okay,
trying to put in the
let's-
result of foo, right?
yes.
I understand that.
Right, so okay, let's
And-
let's
Oh no! Just keep it there. Like, that's fine. Okay. And that's the reason why you add in the lifter. That's the purpose.
okay, let's take this out for a minute.
Okay.
Okay. What do we need to do? What code do we need to return? We need to return filter with something, with something, and with something. Okay, let's go through these one by one. What's this going to be? This is going to be query. But query is a runtime value. How do we know what code to actually put in here? Like we need some code to splice into here like that, right? Because that's what you do with, right? You need some code to splice in. How do we do that? Well, we recursively call the lifter. That's going to be our code.
Okay, I see.
Or in this case, it's going to be query expert.
Okay. No, okay, I understand.
Right?
Right, yeah.
Val
Yeah, it's perfectly clear now.
alias expert lifter.apply. Alias val body expert lifter.apply. Body query expert alias expert body expert.
Okay, and okay, we need this lifter because these things do not exist in sort of in the compile time.
Yeah, we need to actually
like named as.
Yeah, we need to synthesize them.
I see.
That's the point.
All right. Okay.
Right?
No,
This is a value, right? This is a value that we've synthesized in this parser up here, right? We've synthesized this. We need to lift what's in here, right? This is the rest of the AST, right? This is of type AST, right? We need expert of AST, which it is not. So that's why we call lifter to give us an expert of AST.
Okay. Yeah. No. Yeah. Okay. It's perfectly clear now. I'm sorry. It's just
No worries.
late.
We don't need that. We don't need that. We don't need that, and we don't need these variables.
Yep. Okay. Yeah. Yep, it's perfectly clear now.
Voila. 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 There we go. When they say Scala is very concise, it is very concise. I don't think it's too concise. Like, you can understand what's going on. It's not like APL, but it's concise. So you can do a whole lot in very little code.
I mean, no, yeah, I'm just glad that I can understand the ternary operators. That's all.
Fair enough.
It's like, oh god, with all those colons and question marks. Good lord. Like those, yeah, no, I'm telling you, those nested ternary operators can be a real pain in the butt.
Val v equals to, what is that? Foo question mark bar colon baz. Ternary
Yeah,
operator
oh, no.
in Scala.
If
Foo
quite literally if.
bar else baz. Why do you need?
You know, that's how it used to be in. That's how it used to be in Basic. Like what was it called?
Why
QBasic,
do you
Visual Basic?
need a different construct? Make the same
Yeah,
damn
I know.
construct, a ternary operator.
know.
Whatever. Anyway.
Yeah.
So finally property has an ID and it has a name, right? So same darn thing, right? Val ID x equals to lifter dot apply of ID. And that'll turn ID, which is going to be an ident, but it's going to call it recursively, which means it's going to hit this clause. Right?
Okay. Wait, hang on a second. Why is ID a runtime thing? Shouldn't ID be
String.
you know? Oh.
You need to
okay. Yeah,
you need to lift a string to expr of string. That's what this thing does, right? Val ID expr equals to expr of ID, and this is ID expr.
Then why do you need the lifter? Why can't you just do an expr of ID
Huh?
like we did with entity?
Oh, no. Expr
No?
cannot take anything. It can only take constants. It can take a few other things, but expr out of the box can take constants, lists, and a few other things.
Oh, that's why. Oh, that's the reason why it took name for
Yes.
entity. Okay. I see.
Now, actually, what's funny is that in Scala 2, expr actually takes an implicit type class. If this takes some t, it takes a liftable of t. So when you implement liftables, you're actually implementing something that can go into expr of t. And that's how they do it in Scala 2.
Interesting.
Right? That's why you're implementing all these liftable type classes. But anyway, that's more unnecessary details than we need to talk about now.
Okay.
Okay. Right, so again, this is just ident of expr of string of ID, which is an expr of string. Okay. So this whole thing, right, this whole thing is expr of ident, really expr of ident, which is expr of AST. Okay. I don't know. Is this helpful?
Yeah.
I mean, is this comment helpful? I don't know. I can.
Oh yeah, no. Yeah, no, that's good. Yeah,
Okay.
I can. Yeah, no,
Okay.
it's certainly helpful. Yeah.
Right, this is like blah 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 blah. Right, okay. I don't know if this is helpful or not, but sure. Okay, so property. Right, we're gonna do the same thing. So lifter.recursively apply on ID. Same thing on name, except that again, name is a string, so val name expr equals to expr. Right, it's actually expr.apply. FYI. Right, that's how that's implemented.
Mm-hmm.
But again, you don't need that.
You don't need to apply anywhere.
Right, and so this is going to be property of ID expr and name expr.
Thanks.
And again, you're actually splicing them in, so you need to use the dollar signs. But again, apply is not necessary. Apply is not necessary. You can shove this thing directly inside of here. You can shove this thing directly inside of there. Voila. And now, this should be able to compile. Oh, wait, no, hold on. What happened? Oh, right, we forgot our arrows. Syntax error, yay!
Nope.
What did we? Oh yes, org.stuff.ident, expecting org.stuff.ast. Did we make sure ident extends ast? Let's see if we forgot. Oh no, ident extends ast. Ident extends ast. Ident extends ast. Required expert org stuff of ident. Lifter of alias. Oh. Curious. Wait a minute. Lifter of alias? Huh. Wait a minute. Lifter expects an AST. This is, oh. One second. Filter. Ah, ha. Lifter of alias expects, right? What is filter? Query AST, alias of ident, body of AST. Problem. Because this thing, what's the return type of this thing? Right? When we splice, we need to have ident here. So when we splice, we need to have expr of ident. But what does lifter.apply actually return? Whoops, returns an expr of AST, not an expr of ident, which we need because this thing is actually ident. What do we do about that? Well, we could cast it. That should work. Let's see, what's wrong here? Cannot lift the tree. Okay, what do we have? We have entity, we have filter, we have ident, we have property. And, oh, cannot lift, not left. Filter of entity of person, ident p property, ident p of name. We have filter. Ident p of property of ident of name. Why? 1 second. Why can it not lift the tree? Let's make a break and let's do pprint.apply of that. See in more detail. Cannot lift, wait. Let's try that again. Cannot left the tree. Why is this not showing me the new? 1 second. Let me recompile the whole. Now, sometimes you need to pull a trick, which is.
Okay, I'll be back in a moment.
Yeah, sorry, I need
set of
to.
calendar stuff. Yep.
Let's work through something here. Oh, okay. You can't. Oh, excuse me. This is not ident. It has to be. It has to be not ident. It has to be expero ident. Is that gonna work? Let's try that again. Found expr of AST required expr of ident. Instance of network. Voila. Uh-huh. Uh-huh. So what does this mean? What does this mean? Person, entity query, apply person, simple quill 1. And one second. So this is, don't care about that now. Don't care about that now. Oh, clean. All right, fine. Let's clean. And where's the printing macro? Okay. Let's compile. And yes. Okay, everything was fine. Everything was fine. So we were getting what we need to get. We're getting what we need to get. Org.simplequill.entity query of person. Compiling 7 sources.
Okay, I'm back.
Hey, so we're compiling. I'm just trying to figure out what is what. Let's try commenting. Okay, let's try printing this. This is going to be, okay, compiling 7 sources. Entity query. Okay, one second. Compile. Let's recompile this. And, okay. And let's print it during compilation. Voila. That's it. Got it.
What was the change you made?
Oh, it was just instead of doing so originally I had a type description to ident, but that doesn't work, right? Because it's actually expr of ident. But really what it has to be is it has to be dot as instance of expr of ident. That's my
Interesting.
mistake.
So it's cast.
So
Ah.
as sometimes type ascription doesn't work. This is
Okay.
a proper cast. So anyhow, so now the whole thing works. So
Cool.
right, and then here's our compile time tree. Right, we're actually getting back.
Alex, you hello?
Can you hear me? Hello?
Oh, bummer.
Hello?
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 Hello? Alex, yeah, you cut off after you said and then.
Hello? Can you hear me?
Yeah, I can hear you now.
Okay, sorry about that. So I was saying, and oh my gosh, I'm gonna use a different sound device. This is weird. Anyway, sorry about that. So can you hear me now?
Yeah, I can hear you now, yeah.
Okay. Right, so this is our compile time code. This is our compile time query. Query of person, right? This is the compile time code that was returned. So let's have a look at this. Here's the compile time code. Okay.
Oop.
Quoted of query of blah, 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 person, blah, 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 filter, dot apply, blah, 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 entity, blah, 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 ident, key, blah, 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 property, blah, 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 ident, blah, 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 apply, returned, type ascription. There's a type ascription. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. Okay, let's forget the type ascription. We don't really care. Good. There's what we returned. Quoted of query of person. And there's our filter, right? What is this? This is what happens when you get query of person dot filter p2p dot name, because we made p dot name into Boolean, right? It's more like is something, right? We just made name into a Boolean so we could stuff it into a filter, right? The next stage is, of course, to start implementing equal, which is starting to parse binary operations. And we'll get there. We're not there quite yet, but we'll get there in a session or two. So
Cool.
That's what we're going to do next time. We're going to see a little bit more. We're going to start parsing different kinds of operations. And once we do that, we're going to talk a little bit about unlifting. And then basically we might do one more session to just take an example of a construct in the parser and try and port it over. But what's really cool is that sort of as we go, we're learning about the difficulties of parsing, like the whole thing that I covered today of parsing the filter construct. Like that was a very important thing, that like you actually have to mess around with things in order to be able to parse it right.